Hey everyone, my name is Satyam, and we are going to talk about ZK app development with Noir. Okay, little bit about me. I was doing this streams about 4 5 months back, where I dive deep into the Cairo development and dojo. Uh, then things came up. I have a full-time job with a blockchain company, and I got I got married. So all those 4 5 months, I don't know what the what the heck I was doing. So yeah, I mean now I feel I'm in a situation where I can take a time to start doing these streams again. So yeah, here I am. So yeah, we are going to talk about ZK app development with Noir. Just a disclaimer: I am not a very any expert on Noir or ZK. I'm learning. I'm same as you guys. And what I like is to learn in public, learn with other people. So that's the whole purpose of doing these streams, talking things out loud, and maybe yeah, maybe engage with other people, and making this ZK journey a fun and engaging. That's the goal, and asking few questions to myself, and basically having this public accountability. That's what I like about doing these streams. Yeah. So we are going to talk about zcap development, and we are going to start with Noir. uh, I've said multiple times, right? We're going to start with Noir, Noir, Noir. Okay, let's finally start. Okay, so what is ZK? And if you are in blockchain, or you might be hearing this term ZK, zero knowledge, right? But yeah, I mean, what is ZK? So we are going to first of all define ZK. So ZK is basically a technology with which you can prove a statement to somebody, without revealing all the information, without revealing all your secrets. So this is what basically ZK or zero knowledge basically represents. In zero knowledge, essentially there is always a prover, you know. Yeah, I don't know why I can't write inside this, but yeah, prover, and then there is a verifier. Verifier and prover, basically the job of the prover wants to prove something, statement X, to the verifier, and basically verifier basically wants to verify this, that prover is telling the truth, right? So that's the whole purpose is. So the statement can be example statement X can be, I know a message M such that SHA 256 of M is equals to ABC 123. So that's the statement X, and in this the message M is the witness is message M. So for example, let's say this M, you don't want to reveal the message to the verifier, okay, but you still want to prove that this message such that the hash of M is ABC123, right? So that's the ZK problem, right? So how do you prove that, right? And that's the ZK is all about. How do you basically prove this? Okay, and the field itself, like, I I would say that I am not, what I would say, I don't consider myself as somebody who can teach you the very basics or the mathematics of how to do that. But what I feel is that apart from mathematics, what I am focused on is how I can utilize it to create applications, meaningful applications for users, right? So that's the goal. But even though if you want to basically learn more about ZK, I found these ZK whiteboard sessions very helpful. I mean, I've gone through all the videos in season one, and now I have this mental model of what the heck ZK is and the snark is, how these circuits, and the snark, various snark schemes and snark versus stark, all those things, right? I don't know. So it doesn't take that long to load. It must be something wrong, really wrong with my internet. But anyway, so this is basically a ZK haze. Now we are going to basically move talk about the applications of the ZK, specifically in blockchain. So in blockchain, there are two major applications of ZK. One is scalability, and other is privacy. Okay, scalability. Uh, I don't need to talk about why we need scalability, because I think it is pretty much evident that if blockchain are to success, to reach to the people, to the common folks, right? It needs to be as cheap as this master or visa card transactions, and as fast as those master and visa card transactions, right? And this can only happen if there is way to scale the blockchain, right? So that every transaction confirmation doesn't take like 30 seconds or 1 minute, which was previously the case like 2 3 years back on the Ethereum, right? And all this validity and optimistic roll-ups, like optimism, arbitrum, starknet have tried to solve this problem, right? So one of the way ZK plays a role is you can take like a number of transactions, and you can basically create a proof that these transactions executed successfully, and this is like the final state, and you can post this proof on Ethereum. And yeah, like you got all those transactions states can then gets available on the Ethereum, right? And obviously the L2 chain also inherits the security of the Ethereum. So that's the one example of use of ZK. And the side of ZK chains are called scalable chains are called validity rollup, or just like ZK rollup, validity rollup. Yeah. The other use case is the privacy. Privacy is like if you are transferring some amount of money, or doing just any transaction that involves some state change, like change of some state variables, and you don't want to reveal, you don't want to yell at, show the entire people, like entire world, basically every transaction on the blockchain, everybody can see that, right? So in that particular aspect, the privacy comes into the picture, right? And Aztec and Helios are the chains which are focusing on solving this particular aspect. Okay, so we are going to talk about Noir. I'm very fascinated with Noir. It's been 3 4 months since I mean more than 3 4 months, I guess 6 months since I got to know about Noir, and I started learning it. Very elegant language. It's a DSL. Obviously, it's a DSL to develop ZK apps. Basically, ZK apps. You also call ZK apps circuits. So it's the terms are like interchangeable. But yeah, it's developed by the Aztec team. And the things that I like about Noir is it's very developer friendly. The syntax, I feel that I'm able to get most out of it, even though I don't have a very strong background in cryptography. It's backend agnostic. The By backend agnostic, it means is that the circuit that you write in Noir, they can be proven to various proving backends, like Bertenberg and Ultra Blanc, Ultra Honk, and I guess there are some people are trying to support Hello 2 backend as well. And the last and most important thing is tooling and community, right? So community, Noir, and like the broader Aztec community, it's amazing. They have a weekly office hours calls where you can take your questions and get answers from the core team who are actually developing these these tools and libraries and language. And they have a developer questions channels in their Discord, which is pretty active. You get response, like the response time is very fast, like and then the overall broader community members, they're very supportive, like if you run into some problem, or like you want to basically team up for some project, the vibe is amazing. So yeah, so these three things basically are something that you made me decide that I want to stick to Noir rather than some other GKT as well. Okay, so now we are going to go with Noir Lang basic documentation. This is what I find, like if I want to start learning something new, my go-to place is always the official documentation, which is because it's always the most up to date and written by the experts, right? Who literally created the language. Okay, so we're going to read just a bit of it. Okay, so Noir is an open source domain specific language for safe and seamless construction of privacy preserving zero knowledge programs requiring no previous knowledge on the underlying mathematics or cryptography. Okay, ZK programs are programs that can generate short proofs of statements without revealing all inputs to the statements. Okay, you can read more about ZK programs here. Okay, so that's pretty much it about the basic intro, I guess. What I feel about is you only get the confidence once you start writing some programs on the Noir and do stuff on the Noir. So yeah, I already have all of this installation, by the way. So what we can do is we can just create, like very simple project, just hello world project. Okay, so we have this hello world project, and just try to see what are the various bits and pieces of this hello world project is. Okay, so we have this nargo toml file, which is basically some file similar to package.json. It manages all of your dependencies as well as project information. If your project is binary or library, project name, authors, all the various information. Okay. The main file in Noir project is this main.noir, main.nr. nr is the just file extension for Noir files. Okay, so if we can see this entry method fn main, it is taking two parameters, right? Or two arguments, like parameters versus arguments. Okay, one is the public input, this y, and then there is a private input x. Okay, and it's just a one simple condition. It is checking that x should not be equal to y. Okay, so what do we do with this, right? First of all, we can check if this is correct or not. Just nargo check. Okay, and it will create a prover toml file where you can define your inputs. So for example, let's say I just define 1 and 1. Okay, since this constraint, right, this is called constraint in zk language, right? This assert statement, that circuit have this constraint that x and y should not be equal, right? So our inputs are not basically passing this constraint, so it should fail, right? Nargo compile. Okay, nargo, wait, x and y, it should not be. Okay, we are just nargo, what do you say, nargo, well, I think we use just nargo execute. Yeah, nargo execute. Okay, so as we can see, the constraint failed here. Okay, so failed to solve program cannot satisfy constraint. So yeah, I mean, our inputs are not satisfying these constraints, so we can just do now we execute, and you can see that circuit witness successfully solved. And it also basically saved this is the compile artifact, by the way. Okay, this is not the witness, but this is the witness, which is the gz extension. Okay, this is just a compressed file, gunzip extension. Okay, and this is like not readable code. Okay, and we can generate a proof. We can generate a proof. So basically we can take this circuit and we can take the input, and we can generate the proof. Okay, so let's take this circuit, bb proof hyphen v. Now this might be a bit confusing, right, to people who are, mm, who are not familiar with Zeek at all, right? So what we are doing essentially here is, we are taking this program, okay, and we are basically generating, we are generating sort of a blueprint or circuit, right? Circuit, you can consider circuit as sort of a black box. Okay, and that circuit takes a specific type of input. Okay, couple of inputs is private input, and then there is a public input. And what we can do with this circuit is, we can basically prove, we can take our input and the circuit and generate a short proof that, all of the constraints have passed for my particular inputs. Okay, this is what I understand. Okay, so what we are doing here, uh, bb stands for Beretenberg. It's a proving backend. So bb prove hyphen b. Hyphen b is for basically, this circuit compilation artifact. Okay, target hello world json. And then the hyphen w is for witness, and it takes hello world gz, and hyphen o is for output. So the proof will be saved in the proof file in the target folder. Okay, so it saved the file in this proof, which is again, it won't be readable. It's just unreadable string. Okay, and it takes the file and it generates the proof, and now we can verify the proof, right? So we can also take this circuit and generate a verification key. Okay, so verification key is also generated, and now we can take the verification key and proof and verify. Okay, so if you don't get any output, that means basically, uh, it's correct. But if you just change something, let's suppose you change the proof, verification key. Okay, then you can see there is a error. And if you change the proof, let's suppose I'm just, then there is again the error. Okay, wait, wait, what did I change accidentally something? Okay, let me generate the proof again, and let me generate the verification string as well. And as you can see, we don't get any error. So okay, you must not be able to see, but yeah, now if you don't get any error, then that means you have successfully verified the proof. Okay, but this in itself is good, but not really very helpful. I know that, I mean, like like what do we do next now? Like we created a hello world thing, and now how do we move forward? Okay, so I'm working on this project named Noir links, and basically, it's it's a interactive tutorial, step by step. You get to know about all the bits and pieces of Noir, and you get more confidence, because these exercise have couple of codes returns, couple of codes marked as to do, and and there are hints and all those stuff. So yeah, I mean, we can do it together, and yeah, get more understanding of this. So the way to run it, first of all, let's clone it. Okay, Noir links. Okay, what do we do? What do I need to do next? I just run dot slash install.sh. Okay, so it's just doing all the installation thing. Okay, in the meantime, we can, I think that will be done automatically. We can just move to this step. Oh, my internet sucks. And I am on 5G. That's really saying something. Either my stream is taking so much of the bandwidth, or I don't know. Hmm. Okay, I mean, in the meantime, what we can do is we can open this. I mean, we should be able to open it. Okay, I mean, I so basically, if I tell you, the format of this is basically you have these exercises, and as you run command, you will need to do this exercises. So only you need to take care of, only you need to concerned with this particular folder, exercises, and nothing else. That's it. That's pretty much it. Okay, and we'll just run the command. The command is noirlinks watch, and we will complete the code in these exercises. Okay. Noir is an open source domain specific language for construction of privacy preserving ZK programs. ZK programs are programs that can generate proofs of statements without revealing all inputs to the statements. Okay, and this important thing, remove this comment when you are ready to move on to the next exercise. That's amazing. Okay. I mean, this is taking good amount of time, and I guess this is because of the Rust docs. Why it is downloading the Rust docs? That's so silly. Yeah, it's updating Rust. Okay, so I mean, I already have it installed, so I don't need to basically do that. I can just do after. So basically, after this steps is done, you have to run this command. Okay, so basically, you have to run this command cargo install. Mm, cargo install hyphen path dot, and from this, then you will have you'll have okay, let me enter. Okay, so, or I can just move it here. You'll have noir links command available. Version. So as you can see, you have noir links command available. Now we are just going to do noir links watch. Not okay. So you can see that it is running intro 1, and yes, we are up now. Okay, so intro 1, it is just a very basic exercise. There is nothing except reading this, so you just remove this and that's it. Okay, I believe the best way would be to open it somewhere here. Okay, so that we have access to this in the same Noir links watch. Okay, so now we go to the variables one file. Okay, I'll just make this more simple, more small. Variables one. Okay, we also have a readme. Right now there is nothing in readme. Okay, so what it is saying that this will not compile. Can you fix it to compile successfully? So we see fn main, it is z, x and y. So I see the variable declaration is not done. So if we do let z, not let z, and just save it, it wait, it shouldn't be stopping. Let me just see. uh, no links watch, that is fine. Okay, and then once we save it, it should move to the next one. Damn, and that's not good. Integers 1 2. Okay, unable to open exercises less integer. Okay, I think this is incorrect. So okay, just a minute guys, I think I can just right now fix it, you know. Okay, I'll just fix it in the main repository so that nobody else also faces this thing. Integer 1 2. Okay, fix exercise integer, exercise name. That's great. I mean, I got to know about my own bug. Okay, so we are going to do Noir links watch again. Okay, now we go to variables one. Variable one already done. We now remove this comment, and it should take us to variable two. Okay, so variables two. What is the issue with this one? X field, if x equals to 10, x is 10. Okay, so here we haven't defined any value to x, so we can just do 34. Okay, and it will compile. One thing that I would suggest guys is disable the Noir extension if you have it, because then otherwise it will give you a lot of help, which is not really useful if you are learning. So I would suggest disable the Noir extension if you already have it. Okay, now variables 3. So variables 2, we are going to remove this comment. Variables 3, what is x field, println f of x is, this is string formatting, so we can just define any value here. Okay, let's say 2. Okay, so it will compile now. Okay, this is like very small exercises, but as we move forward you'll see that the level of the exercise are going to really tough. Okay, okay, now x is equals to 3, then str x is 3, println str x is 5. We say don't change this line. Okay, so we are basically changing the value of the variable x, but variables in Noir are by default immutable, so you can't just change the value. So if you want to make the variable mutable, you have to explicitly define them, explicitly make them mutable with the keyword mute. So okay, so we have made them explicitly clearly with the let mute x3. Okay, and still we are getting the error f of wait, what it is saying, let str println println is fine. Wait, there is some issue. Okay, if I guess these two lines are causing these two lines are causing this issue somehow. Yeah, and now we need to know what this issue is. So let x is not fine. Okay, so we can't define the string like this. Okay, so let's see string formatting in Noir. String, okay, so I guess you can use this. Okay, I mean, sounds okay to me. F, I guess you can't use the mutation variable, mute variable, if I am correct. Okay, this is interesting to say the least. What if we just overshadow it? We then get to know if this is the issue with the no. Okay, I think I found it. What if we if maybe str is a reserved keyword? Yes, that's the issue. Okay, we can't use the str word. Okay, so this str is the reserved keyword. Uh, so we can't use this like this. Yeah, we were using reserved keyword and we got it. Again, very good. I don't know, like what I was thinking. Maybe I must have changed something, but uh, I'm going to now fix it. Which exercise it is, by the way? Variables 4, str1, or maybe like there are some version changes which is causing this. Okay, so okay, I'll commit it later. Maybe there are other things, but let's continue. I'm not done. Okay, so variables 5 is there. Then what we are doing here, don't change this line. Okay, f number is number, don't rename this variable. Obviously we can do this, we can do a shadowing, we can redeclare a variable. So like the new variable will shadow the previous variable, so we can just redeclare it, and I guess that's pretty much it. Don't change this line. Wait, let number is 1u8. Can we, is this because of this one? Okay, I mean, you can't have a can't I mean, this is definitely some version related changes we are seeing now. Because okay, so variables 5, I guess. Okay, so the exercise was incorrect. There needs to be you can't have like underscore U8, but in Rust you can. I guess in Cairo language you can. If I remember, previous versions of Noir also had it, but maybe it's a recent change. I don't know. Okay, so let's move on to the next exercise. Okay, variables 5. This one is, I guess, variable 6. Okay, global println. Okay, this one I know you need to define the type of the variable in advance if the variables are global variables. Damn. Global small number is ah, there needs to be, there are a lot of errors. Okay, again I'm going to commit first of all these three of them. X variable exercises. Okay, so moving on, uh, moving on to, wait. Okay, so moving on to the next exercise, we get if if exercise. So do we have where we can go in control flow? Okay, so in control flow we have this light age equals to 15, light mute, can vote. Okay, change this line. Okay, so can vote should be true. So if we just change the line to 25, I think that's going to be passed, because the test is basically asserting that users should be able to vote. So here if we make the age greater than 18, the test case would pass. The easy one, you know. Okay. Okay, so the next one is grade calculator. Ah, this one looks like a big one. Make the tests pass by completing the grade calculator function. This function should return a letter grade based on the score. Okay, so score greater than 0. If score is greater than equals to 90, grade A. Else if score greater than equals to, so 80. Okay, grade B, grade B. Okay, else if score greater than equals to 70, grade equals to C. Else if score greater than equals to 60, grade equals to T. Else grade equals to F and semicolon. Okay, so what is the, are we missing a semicolon somewhere? guess B. B have something. Uh, okay. What is the issue here? Expect a semicolon between these two statements. But I see all the statements have main.nr. Okay, so I'm going to look at if else here, control flow. There is only if else, not else if. Hmm. I guess that's going to be the issue, right? Right. So if your score is greater than equals to 90, I guess we just remove this. Okay. And hmm, what is the issue here? I guess you are also closing the if. Hmm. Else if is not there. Okay, so basically we are going to start grade is equals to A. The parenthesis is not needed. I don't know. I mean, that's the issue. Okay, let me do something like this. Else. Okay, I'm sure this will definitely work. But this is a weird way. Mm, if grade is equals to 0, else okay, I am going to start from the very beginning. Okay, if score is greater than 0, grade equals to A. Else if score greater than equals to 80, grade equals to B. I'm just going to see if the okay, so that means else if is supported. That means I was missing something different. Score is greater than equals to 70, grade equals to C. Okay. Else if score greater than equals to 60, grade equals to T. See, that means there was some issue with some syntax. I mean, it's it's mind-boggling. Anyway, so you can see. I mean, it's not easy. I mean, you get stuck. Damn. Okay, so now we go to count factors. Okay, count factors. What we are doing in count factors? Let mute count factors. Complete a code. Remember, a factor is okay. So if uh, if you know n percentile I is equals to 0, count factor count equals to count plus 1. That's it. Okay, so guys, we have covered 3 exercises. Basically, variables, intro, control flow, and yeah, maybe tomorrow's stream we are going to cover other exercises. But in the meantime, feel free to try the Noir links, and if you run into any issues, just let me know. And yeah, I mean, you'll be able to find my Telegram in the stream description as well. But if you are just looking, this is my Telegram. Okay, I am going to export to link and copy this link and basically put this link in the stream as well. Okay, thank you.